Oh yeah, look out. Okay, today's assignment, working on the blue packet. Passed that out a few days ago, but it's more direct and tangible. Everyone uses blue packet. We need all the packets. This one? I was like, wait a minute. Okay, as much of the Unit 3, much of the blue packet is review. It's not anything new, just, again, practicing AP questions with things you already know. However, problem 8 uses a rule from the pink rule sheet that you haven't used yet, so we'll do this one together. You notice, no one talk now. Make sure your phones are put away. When I read the problem, here's a function, that's nothing special. I see that all the time. Okay, there's a key clue, and I've learned from doing lots of AP problems that when they give me this clue right here, I need to be remembering a very specific rule from the pink sheet. The rule on the pink is this one. The derivative of an inverse function can be written as 1 over f prime of the inverse. So I've actually never seen an AP question where they were dealing with an inverse function where they didn't end up using that formula. Okay, it doesn't mean they won't have some brand new question that might, but I've never seen one. So whenever I see that they introduce the inverse function, I always write this down from memory. So you didn't need that memorized for Unit 2, but you'll need it memorized now. So please.
On the bottom of the thing, how it says f prime of the inverse function. So if you're finding a derivative, when you just keep doing that, keep getting the inverse, as you find that f prime of the inverse again. Does that make sense?
Say it one more time, Jonathan.
So in your equation you have right there, you have 1 over, and then it's f prime f inverse function, right? So if I was to keep going, I would find the inverse of that f negative 1 again, because there's an f prime in front of it, right? So when you just keep going forever.
Somehow you're, so Jonathan's question for the video is, isn't this going to be kind of an endless loop? That's what you're saying, right?
Yeah.
Somehow you're misinterpreting what f inverse and f prime are. But let's go further and see if it answers your question. Is that okay?
Yeah.
3 points for a good question. The ultimate goal of the problem is to find this, g prime of 2. So what you should be writing on your paper, again, we have reached the point in the year definitely where good notation is going to make a difference between a good test score and a bad test score. Like whether I come check your notation or not, it doesn't really matter. What's important is that you're using good notation to not make errors. So I've got to find g prime of 2. So you should write on your paper, I need to find the derivative of g. But I need to find that, once that derivative is found, I'm going to evaluate it at an x value of 2. So write that down. Now is where the AP test writer is expecting you to make some connections. So I want to see how many in the room can make the connection. I'm supposed to be finding the derivative of g at an x value of 2. Based on the clues, this is equivalent or the same as something else. Like I can write, oh, this is going to be the same as d over dx of blank. Who knows what goes in the blank? Like you're just looking for things that are equal. It's all about paying attention to the equal sign. I'm supposed to find this. because they asked me to find g prime of 2. And these two things are the same. The item in blue and g prime of 2 are exactly the same thing. So that's why I wrote the blue. But according to the clues, the blue is the same as some other thing. Like you're just looking for what's equal to what. So Matt's in, Nelson's in, Jonathan. If I said your name, take down 2 points. Brinley, Sam, Jackson, Alana, Daniel. There we go. So Daniel, what do you see?
The key to 1.
2 points. I can't really use that because this doesn't mean. So Daniel's suggestion was, let's take advantage of the fact that it says up there that g of 2 equals 1. True, but this doesn't mean plug a 2 in for g and then take the derivative. This means take the formula for g, find the derivative, then plug in 2. So I really can't use this yet. Other ideas, hands? Let's go, Autumn. So what Autumn noticed was they tell me that g of x is exactly the same thing as f inverse. So right here where I've written d over dx of g of x, wherever I see g of x, I can put f inverse instead because they have been declared to be the same thing. So that's what I mean by you're just looking for where you can use the equal sign appropriately. That's a place where I can use the equal sign. Because g of x and f inverse are exactly the same thing. So g of x and f inverse are the same, so I can make that replacement. Okay, how many would have said that had I called on you? 2 points, 3 for Autumn. Okay. You're going to want to talk more about it. Like I say it a lot, but we really are, you have to be good at recognizing equal. Like what is the same as what? And then you just make replacements. So now, this is exactly the same thing as the rule on the pink sheet right here. So I'm going to plug in this in its place. So this blue box right here is going to equal this blue box. So in place of d over dx of f inverse, I'm going to put 1 over f prime of f inverse, but I'm doing it when x equals 2, so I can put a 2 in right there. Questions? So really the key connections here were reading the problem, I recognize that they are talking about an inverse function, so I right away think of using this formula. Next thing, identify what they want. They want me to find g prime of 2. So I notice that g prime of 2 is this. I do exactly what Autumn said. I notice that g of x is the same thing as f inverse. So I make that replacement. Use the rule sheet to get here. So now I'm looking to find the value for f inverse of 2. So I'm back to looking for equality, looking for something that's equal to something. There's a clue in the up here that tells me the value of f inverse of 2. Who can see it? Come with the hands. talk to each other for a minute. Let's try and get everybody to see it. Heads up, who sees it? Come on. Who can see it? Allison.
I would say it's equal to 1.
They tell us that g of any x is exactly the same thing as f inverse of that same x. So therefore, if g of 2 is 1, f inverse of 2 must also equal 1. Again, I'm just paying attention to equal. How many saw it? 2 points, 3 for Allison. They want me to talk more about it so you can for sure see it.
Sorry.
Cool? So this becomes 1 over f prime of simply 1. I don't know if this is answering your question, Jonathan, though.
Well, I figured out where I'm kind of confused with what f prime really means. See, I thought it was the exact same as dy over dx. I thought they were the same thing. But I can see that you can't quite do really the same.
Let me see if I can answer that. 3 points for Jonathan. His question is, what does f prime really mean? Let's see. Okay, we have a formula up here that says f of x equals x cubed plus x. And if I apply the derivative operator to both sides, okay, easy extra credit. Just raise your hand if you're comfortable with that. Like, who looks at that and goes, oh, that, I get that, it's no big deal. Your hand is raised, give yourself 2. Okay, look hard at the board. On the next step, I want to do something I don't typically do. Look here. You find the derivative of f of x. If you'll get used to using the chain rule, it'll prevent some mistakes in the future. This is the derivative of f of something. The derivative of f of something is f prime of that same something multiplied by d over dx of the something. That's equal to 1. That's why we don't usually write it. That's why we're accustomed to saying that d over dx of f and f prime are the same, like they are. But one difference, and maybe this is what, I'm hoping this will help Jonathan's question. This right here is telling you to perform an operation on f. So here's our formula for f. This notation saying we need to do something to that formula. F prime is the symbol that represents what we ended up with when we did that to the formula. It's like f is a formula, f prime is also a formula. It's going to end up being 3x squared plus 1. So I don't know if that helps or not, but when I look at this, I see that I'm going to do something to the formula for f. When I see this, this is the result of what I did. Does that help a little? Anybody else? Cool. So, back to looking at the board. Raise your hand if you can tell me what f prime of 1 will equal. Hands up. Like, again, you're just looking to see what is equal to what. It's like lots of AP problems are going to be like this in the future. You just keep looking for, hey, this is the same as this, and so I can put them together. Like, all the clues you need are on the board. I got to find the value for f prime of 1. There we go. Let's go, Jake.
Is this 4?
Tell me how you found it.
I plugged in the 1 for the x, so 3x squared would be 3, and the plus 1 is 4.
Perfect. So Jake looked over here and saw the formula for f prime for any x. All we have to do is substitute a specific value of x. We get that. How many saw? Points 3 for Jake. We want to talk more about it. So we're done. Because if you follow the equal sign, we started by saying we want to find g prime of 2. That's the same as this, which is equal to 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 1 over 4. So, question? You want me to talk more about any part of that? Please.
Can you go over the ending part, like the green to pink last part?
So, are you okay with this one here?
Yeah.
So are you okay that f inverse of 2 is simply 1?
Yeah.
Awesome. Are you okay with how we found the formula? So it goes back to kind of what Jonathan was saying. When you see this, you should be thinking, oh, I need to know the value of the f prime function when x is 1. But we were able to find the f prime function because we could use our derivative rules and the formula for f. So over here we found a general formula for f prime, meaning we can find f prime of any x. So all we did now was make our x specifically 1. So f prime of 1 is 4. So this whole thing became 4, hence 1 over 4. I don't know if that helped though.
Yeah, no, it helps.
2 more. Anybody else? Cool. So stop that one.